Good morning, everyone. We are excited to present our topic on comprehensive overview, continuous authentication and authorization in microservices with zero trust. I am Saranga Srikanthan. I will be covering the first part of the presentation. After that, my teammate Rovinda Jayasekara will continue with the later sessions. To give you the quick overview, I will first talk about introduction, challenges of authentication and authorization in microservices, continuous authentication in microservices, continuous authorization in microservices. After that, Ruvinda will cover to discuss technology and frameworks for continuous authentication and authorization, implementation challenges and trade-offs, future trends, and conclusion. Okay, imagine you are logging into the Netflix. You enter the password once and you stay logged in. But if the Netflix kept checking every second whether it's really you, it sounds unnecessary, right? It's make annoying, right? But in the high security environments, that's actually the best way to protect data and system. This is called continuous authentication. It consistently verifies user in real time. Why do we need this? Because traditional authentication, we are locking the ones stayed locked in, doesn't work well in microservices. Microservices are replacing the large monolithics of your architectures because they are scalable and efficient. But the problem is they are highly distributed. So must be continuous, not just in locking. That's where zero trust security comes in. It follows a simple principle. Never trust, always verify. Every user, every service, every device must continuously prove they are authorized before accessing anything. That's the thing here. Think a bank with a different departments. If security is weak, is in just one department, the whole bank is at risk. That's why we need continuous verification. So one weak point doesn't bring everything down. Now let's look at the challenges of authentication and authorization in microservices. Microservices are break down large application into small services, which makes scalable and efficient. But this is also makes security more difficult because services must consistently communicate, increasing the attack risk. One issue in consistent security policies, if one services is weak, hackers can exploit and move across the system. Another issue is performance. Frequent security checks and slow down everything. Every whole department slow down. That's the point. Thinking that's a company, it's a HR department, finance department, IT department, all use the security system. If HR department is vulnerable, hackers can break in and access other department also. That's exactly the risk in the microservices. To solve this, we use continuous authentication and authorization. Instead of logging in once and stay in login, continuous authentication keeps checking if the user is still legitimate throughout their session. This is done using the JSON web tokens. Web tokens like a digital passport harried with each request. That's the thing. And another method they are using that manual TLS, which ensure that both the client and server authenticate each other. We also use behavior analytics, which monitors login patterns and detects the unusual activity through the biometrics measurements. Think if you are logging into the email from new device, it asks extra verification. That's the continuous authentication. It keeps checking if you are really you. Okay, now you are verified user. We need to control what they can access. This is the continuous authorization. Here, authentication checks who you are, but authorization check what you can access. In microservices, access must be verified every time a request is made by the user, not just one blocking. We use here policy-based access control, which grants the access dynamically based on the real-time condition, and least privilege access that also ensure the user only get the minimum access necessary. Think of the obvious batch system. Just because employee enters the building doesn't mean they can access every room. If they try to enter the restricted area, security check their clearance every time. That's the continuous authorization. Now, we covered authentication, authorization, and security mechanism. I will pass it over to the reviewing group who will discuss the framework to conclusion of our research.
Hi, I am Rayandu Lakmal Jayasekara. In today's digital landscape, traditional security models are no longer sufficient. A zero trust architecture ensures that no user, device, or service is internally trusted. Instead, continuous authentication and authorization are necessary to prevent unauthorized access. Let's explore key technologies, challenges, and future trends in this space. Technologies and frameworks for continuous authentication. First, we have mutual transport layer security, which ensures secure communication between services, especially in service measures like Istio. Next, JSON Web Tokens provide a lightweight method for verifying identity securely. Finally, multi-factor authentication strengthens security by requiring multiple verification factors. For authorization and policy enforcement, first one is role-based access control, which grants access based on predefined roles. The attribute-based access control evaluates real-time factors like location and user behavior. Service measures like Istio, Linked, Cilium enforce security policies while integrating with identity and access management system. For real-time monitoring tools, Falco detects unauthorized activities in Kubernetes. Open Policy Agent enforces policies within microservices. Artificial intelligence and machine learning improve threat detection and adaptive security. For identity management, identity and access management enables SSO and multi-factor authentication. SPF, which means Secure Production Identity Framework for Everyone, provides secure identity management and certificate-based authentication. Next, I will discuss implementation challenges and trade-offs. While Zero Trust enhances security, implementing it is not without challenges. The integration complexity means adapting Zero Trust to legacy system is difficult, and performance overhead in which the frequent authentication can increase CPU usage and latency. Next one is operational complexity. Because continuous monitoring requires expertise, there can be cultural resistance when organizations may hesitate to adopt new security models. Need cost and resources for the implementation, which requires significant investment. Balancing security and usability is a challenge because excessive security can hinder user experience. Finally, privacy and compliance. When applying security, the regulations like GDPR and HIPAA must be considered. Next, I will show what are the future trends. First one is multi-cloud strategy, in which security must work across multiple cloud environments. Continuous service mesh adoption use tools like Istio and ambient meshes because they make integration easier. In modern world, the artificial intelligence and machine learning integration is required for real-time threat detection, and also adaptive security policies will improve security. Next one is dynamic access control, in that risk-based real-time decision will enhance protection. Finally, advancements in cryptography. The post-quantum cryptography will future-proof authentication. Finally, I present the conclusion. Continuous authentication and authorization are essential for securing microservices. Unlike traditional models, Zero Trust requires real-time verification and dynamic access control. By leveraging JSON Web Tokens, mutual transport layer security, attribute-based access control, and identity and access management systems, organizations can enforce least privilege access while maintaining flexibility. Despite challenges, future advancement in AI, automation, and cryptography will enhance zero trust security. making microservices more resilient against cyber threats. Thank you for your watching.